I am Madhurima and my project is about using a mathematical technique called fractal dimension analysis to distinguish between cancerous and benign tissues. My research question was, is it possible to use the box count method of fractal dimension analysis to determine whether a tissue is cancerous or not, and if so, is there a clear threshold of distinction between cancerous and benign tissues? The images that I used, such as these, show that in general cancerous tissues are more complex than benign tissues, but it is not always easy to tell to the untrained eye. So fractal dimension is the measure of the complexity of an object, like these images. This can be measured using the box count method, which overlays grids of different sizes on the image and compares the size of the squares in the grid to the number of squares filled. The program that I used to run the test was called MATLAB, and it plots the different data points from the box count test, and the negative slope of this line is the actual value for the fractal dimension. This program allows you to set different levels of grayscale or contrast before running the test. So this is the data that I collected, which shows the average fractal dimensions at 3 different levels of grayscale. I was very interested in the change in fractal dimension over grayscale, so I decided to compare this in prostate tissue, comparing a benign image to a cancerous one. As you can see, the fractal dimension of the cancerous tissue decreased at a much less rapid rate than that of the benign tissue as the grayscale level was decreased. So I decided to plot this for all of my data, and I found that the trend still continues, as you can see in this graph, which shows the averages of all my data. So my result was that you cannot use simply the fractal dimension to determine whether or not the tissue is cancerous, but you can use the rate at which the fractal dimension changes over the grayscale level to make that determination. This result could have potentially huge applications for the medical world in quantifying cancer diagnoses based on histological data, and would allow computers to do preliminary screenings before having physicians do more in-depth tests to diagnose cancer.